let us now explore our next topic about the word electricity. Electrical energy, electron, current flow. Those are the basic vocabularies that we often heard from time to time upon learning those important terms. The word electricity, no? It's not just only theoretical concept, but electricity comes in place with several contributions in our daily life activities throughout the community and different parts of the world, right? So let me ask you, how electricity important to you every day, every night? Okay, give me some basic uses or beneficial contributions into your daily activities. Okay, iPhone, do you have any idea? How is it electricity useful or beneficial to you? For your gadgets, right? So electricity important. Now the power of electricity conquers your gadgets, no? Because your gadget, your appliances, your devices at home, your laptop, your computer, mobile phones, your internet connection, your Wi-Fi connections, it will not work without the power of electricity, right? So it's very important. Every time we do our laundry, no, we want to see or want to watch a news report. So we need to turn on our television, okay, in order to be updated about the different informations, no, through television report or broadcasting, right? So what else? Because of electricity, no, our transportation took really fast, no? Everything going easier and faster because of electricity. Our air condition, our refrigerator, our computer, your iPad, our projector, okay, works really well because of the power of electricity. So now we understand, no? It's very broad, no? To understand where is that electricity coming from? Who discovered and invented this application, no, of electricity? And why this considered, no, as very important tool in our daily life activities? How does the reaction takes place when it comes to electrical energy? But one thing that we need to know, where is that electricity coming from? Right? And who is the first person invented this type of tool? Okay? And for our daily life activities. Would you imagine that, okay, everything started from a small thing, right? Until then, we reaches to this era or modern technology era or modern years, that everything, electricity important as a backup support, no, in different aspects of life. Okay? Household appliances application, transportation application, machinery application, no? Programming, communication, and information application. Right? Manufacturing and factories, company, laboratory, hospitals. Okay, electricities are applied. Right? In various areas, different parts of the world, okay? We are not left behind already. Okay? Asian continent, European continent, US continent, all parts of the world, different parts of the world. Okay? Just only few percentage that some people won't have their own electricity. Those people lived, no, among the tribal or very far from civilization. They still have to adapt, no, the traditional thing, no, not depending direct to the power of electricity, but most, no, okay, around 60 to 70%, okay, or 80% people adapt this kind of new tool or technology that helps to run through with our business and daily life livelihood application. Right? So we have to know first, what are the sources? And what is the very important component or charges present in this object? How do electrically charged objects differ from each other? How do objects become electrically charged? How do electrically charged objects interact, okay, towards each other? So, when can we say that it is electrically neutral? Let's go back to our previous topic related to subatomic particles. Okay, do you guys still remember what are the different subatomic particles? One, electrons. Next, protons. Next, neutrons. Now let's find out what are their electrical charges. Is it positive, negative, or zero charge? So, what is the charge of electron? What is the charge of electron? Negative charge. Negative charge. Minus sign. What is the charge of protons? What is the charge of protons? Positive charge. Positive charge. Plus sign. What is the charge of neutrons? What is the charge of neutrons? Zero charge. Zero charge. So what does that mean? Try to look at the difference between this diagram. No? So the number of negative charges, okay, in this blue indicator and the positive charge, which is the red indicator, are equal or neutral. So, means to say that there is a presence of neutron. Okay? So, neutrons has only zero charge. So, another one means to say that there is 6 positive charges and 6 negative charges present. So therefore, okay, 6 plus negative 6, that will be 0. So there is 0 net charge the object turns neutral. And what is the charge of neutral? 0. In other words, this is the representation of neutron. Understand? Okay, let's proceed. When can we say that it is electrically charged? So in this condition, remember, of having an balanced amount of positive charge or negative charge. Means to say that positive charge is greater than the negative charge. So 8 positive charges and 6 negative charges, okay, joined in one place in this orbital. So therefore, the net charge is positive 2 because this represents as the presence of protons. So the object is positively charged. So if it's charged positive, what does that mean? What is this subatomic particles? This is what we call protons. Okay, protons. However, when we have 6 positive charges and negative charges, 6 plus negative 9 is equals to negative 3. Now, the result would be electrons, negative, right? So, the presence in there, the net charge turns into negative 3. 6 plus negative 9, right? That will be negative 3. So, the object of this in the orbital of subatomic particles is negative charge. When we say negative charge means protons, electrons. Electrons. That's electrons. So, to continue. If we have electric charge, we also have electric discharge. Okay, what is meant by the word electric discharge? Electric discharge is the process of an unbalanced electric charge becoming balanced. So say for example, in this body A, okay, as you can see, the left and right corner, there were indicators in these round orbitals, right? So pure 100% positive charges, body A. Body B, okay, 50% negative and 50% positive. So body A is positively charged and body B is neutral conductor. So what would happen? Bodies A and B on contact. So be joined. There is a contact force between the two. So therefore, okay, what will be the reaction takes place? Body A tends to be negatively charged after separation and body B tends to be positively charged after separation. Okay? So therefore, once attraction or the contact force takes place, okay, there were attractions between positive and negative. Okay, you often heard that one or you often see that one in a battery, right? There is positive side and negative side or positive or negative terminal between sides. So therefore, body A tends to be negative charge, okay? So it consumes this one, the negative charge, okay, attracts and consumes the area of positive charge. So what would happen next? Okay, the negative charge conquers the orbitals around 80% and the remaining 20% will be positive charge. And what about this one? So the exchange takes place. Okay? So on the right corner, there were 80% of positive charge conquers on this portion, while the remaining 70 to 80, 20%, the remaining 20%, okay, will be the negative charge. So there is what we call an exchange contact force. Okay? So therefore, body A tends to be negative charge after separation and body B tends to be positive charge after separation. And that is why our battery, no? When we are going to connect that one with other units, okay, or any appliances like flashlight or emergency light, okay, we were able to see, no, how the light bulb, okay, light up. Okay, every time we switch on, no, we see the indicator of the bulb lighting up. Okay, so we also have insulator and conductor. No, we're going to continue this one later. What is the difference between the two? Between electrical insulator and electrical conductor. All right.